Hello once again. It's finally time. We're gonna actually do a little bit of putting everything together. So depending on how this video goes, depending on how long it takes, I may end up splitting this up. So just be prepared for this to potentially be two different videos. Um, but if you have any questions, feel free to email me just like normal. Here's my email address. Um, I'll be sitting by my computer most of the week, so just get a hold of me if you need to. So today we're going to finally take care of putting everything together and find the area of a regular polygon. We talked about how to find the area of a triangle in a bunch of different ways, and then count how many triangles the pieces were cut up into, and then multiply by that many triangles. We're going to use the same idea. The one difference is that since now we're no longer going to be able to deal with finding the area of a triangle the normal way, we're going to use the trig way that we talked about in the previous video. So be prepared. Here we go. This is what we talked about in the last video. If you haven't checked that one out, it is a prerequisite to what we've just been doing. So go back, look at it, make sure you know how to do this before you continue. Alright, so what I want to be able to do is I want to be able to use this formula. Let's talk about how. This is going to be the easiest version of doing these problems because pretty much everything has been done for you. If you look, we have a octagon. Let's see. We have an octagon, and the thing of it is, this octagon, we're going to split it up into pizza slices, just like we did last time. We're going to do this all the way around. Do our best to make it look nice, but you know, life is not always great. But we go through, the whole point is that how many of these are there? There's 8 of them, right? It's an octagon. We make 8 pizza slices as we go around. I'm not going to do all of them. I don't think I'm just going to do these. But the whole point is you've got 8 pizza slices, which means each of these pizza slices has the central angle the same, right? And each of these is a radius, so each of these is 5. So what we can do is figure out what this central angle is. Well, all of them together make a whole circle of 360, and then we count there's 1, 2, 3, 4, 5, 6, 7, 8 of them. 360 divided by 8, that had better be 45, right? Let's get a color that we can see. That might be helpful. This is going to end up being 45 degrees. If you do that, 45 times 8 gives you 360. That's what we're expecting. So, now that we've done that, we have this side is 5, this side is 5. So we've got our A, our B. We're going to use this formula again. We've got our A, that's going to be 5. Our B, that's going to be 5. And our x degrees, that's going to be 45. So we can literally just go ahead and maybe make our line width a little bit thicker because it looks kind of weird. And say, all right, well, here's the area. 1/2 a b sine x. Our a and our b are both 5. Our sine is going to be 45. That's sine of that should be a 4. the point is, now we know what one triangle is, and we know that there's 8 of them. So once we put this into our calculator, I'm gonna call up the calculator on my phone, and we're gonna type it in. 1/2 times 5 times 5 times the sine of 45 degrees, and that ends up being 8.83883 4765, and so on. And we're going to hold on to this number for a second. We don't want to round to the nearest 10th yet, because we're not done. This is one triangle, right? This is one of them. We don't want just one triangle. We want all of them. There's 1, 2, 3, 4, 5, 6, 7, 8 triangles here, right? So we're going to take the number that we got in our calculator, the whole thing, not just a rounded off answer, but the whole thing, and multiply that by how many triangles there are. There's 8 of them. The whole thing, when we multiply everything together, we end up with, this is going to be our final official answer, 70.71067812. And again, final answer round to the nearest 10th goes right here. We look at that. That's not big enough, so that's going to get crossed out. 70.7, and our units are going to be centimeters squared for area. Centimeters squared. So when we have the radius of our polygon, this is a real easy problem, a super duper 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 easy problem, because we could just go through and find the middle angle here. Each of these radii are going to be the same, so A and B are the same. And then find one triangle times how many triangles, and then there you go. That's all it is. Let's do a couple more problems just so that we're all on the same page. Here's a second one. I'm going to give you a little bit of time to do it. Hit the pause button, and I'll be here waiting. Okay, so here we go. Just like before, we are going to split this up into triangles. You're going to go through and you're going to figure out that there's 5 of them. This is a pentagon. That's not a surprise. And the whole thing here is these are both 2 kilometers. If you find out, you take the pizza and you slice it into 5 slices, 360 divided by 5 is 72, right? 360 divided by 10 times 2, 72. And now that we have everything we need, there's 5 triangles. One triangle is going to be this right here. We're going to plug it in. 1/2 times 2 times 2 times sine of 72. And we're going to go through, we're going to plug that into the calculator. Again, this is one of those things you could sit here and do a little bit of number crunching and make it simpler to plug in, but why? There's no reason. It's already here. You might as well just plug it into the calculator the way it is. 1/2 times 2 times 2 times the sine of 72. You do that, and your area for one triangle is going to be 1.7 9 0 2 1 1 3 0 3 3, and I'm writing every single digit out here on purpose because I don't want to round yet. I don't. So leave it here, leave what you got here, and then, it's in your calculator. You can just now say, well, there's 5 of them, so times 5 to get the whole thing, times 5, and you end up with 9.5105 and it keeps on going. We don't need those. We care about rounding to the nearest tenth. And again, you look, that's a 1, which means that this is not big enough, so we are left with approximately 9.5 kilometers squared for our answer. That's the whole thing. One more. So, I wanted to give one of these just because I wanted to remind you that you do not have to do hexagons this way ever. If they give you the radius of the hexagon, you can go through, find that the base here is 14, the height here is 7 radical 3, just like we did in the earlier video. And then you can find the perimeter, 14 times 6, and 1/2 times the apothem times the perimeter, and you have your answer. You can do it that way all the time. You're free to. That's fine. I'm going to show you how to do it this way just in case you like this way better. Once again, we count. We've got 6 triangles that we're making up. Each of these is 14. And since there's 6 triangles, each of these angles in the center is 60. We can do the same thing we did before to show why that's true. 1/2 times 14 times 14 times sine of 60. And we can plug that into the calculator. And we end up with one of these triangles having a area of 84.87048957. And then there's 6 of those triangles, so times 6. And you get a final answer here of 509.2229, yada 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 yada, rounding to the nearest tenth. This 2 is still not big enough. We're going to leave that as 509.2 units squared for your final answer. Okay, so going forward, here's where we come into slightly more complicated times. I now want to be able to do this given a side length. So in order to do this, what we're actually going to have to do is we're going to have to make a trig function, because we don't know exactly what the ratios are, like we did with the hexagon, like we did with everything else. We are going to have to deal with this slightly differently. Now I'm going to go ahead, I'm going to draw this out just like we did before, because our goal is still to get our radius, but the difference here is going to be that now I'm going to actually need to make a right triangle to find this radius. Now for those of you sitting at home, you're looking at this and going, okay, well, I only have the information down here, and I'm trying to find the radius, well, that means I'm going to need to use sine, right? Opposite hypotenuse. It does help to make a triangle, a right triangle, because then, you know, you can actually look at what you're doing. So let's make a right triangle up here real quick. Yeah, it's not so good, but we're trying. There we go. So if we take our angle, we go through, and we went through back and we did this before here. We found that that angle in the middle here is 72, right? This one. Let me get yield highlighter. There we go. This whole angle right here. We found that that was 72. This is still a pentagon, and so that middle angle was still, in fact, 72. But now, we went through and we cut it in half, right? So since we cut it in half, the angle that's here, the one that we're going to actually use, is half of 72, 36, right? So we're going to go through here, and we're going to actually make our little thing here, 36 degrees. And this whole side is 6, but we don't care about that. We care about the one piece here, right? Well, what's half of 6? 3 feet, right? And what we're trying to find is the radius right up in here. So, once again, as I said before, those of you who didn't see before, it's easier to see now. We've got a sine function, right? Sine is opposite over hypotenuse. So, basically what we're doing here is we're taking one extra step to figure out the radius, and then we're going to come back and we are going to do the exact same thing that we did in the last problem now that we found the radius. So let's find the radius real quick. Sine of 36 equals opposite over hypotenuse, and we're going to cross multiply and divide here, so we end up with 3 over the sine of 36. If you are having trouble seeing how we got from here to here, go back, check out the video that I did, the review of trig. At this point, I want you to be able to get from here to here pretty easily. So going from here to here, and then this is our radius. Now, you could theoretically leave it like this. That's totally cool. But you do not have to. You can put that into the calculator and get something out of it. If you do, typing it in the calculator, you end up with x equals roughly 5.1 something. Now here's the thing to keep in mind. Again, if you're going to use this number, you must use all of that number. Remember, as I said before, we don't round in the middle of a problem. We have to use the whole thing. Luckily, it's saved in your calculator. You can use the answer button and it'll save some of the heartache. But if you do not, and you have to type it in 2 whole times, that is okay. I'm willing to make that sacrifice for you. So, we're going to go ahead, and now that we have our radius, this is our radius, right? 5.1 something. Yada, 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 yada. Now we can go back and do literally the exact same thing that we just did. 1/2 times the radius times the sine of the middle angle here, and now we want the whole 72 degrees, right? We don't care about the 36 anymore. That was just used to find the missing piece. You can throw this in the trash. We are done with it. 72 degrees is what we're using, just like we did in this problem. using 72 degrees because that is the middle angle for this problem. So let's go ahead and let's plug everything in. Area equals 1/2 times, I'm going to write it out like this, 3 sine 36 squared, because it's the same thing times the same thing, so that's squared, times the sine of 72. So now that I've done this, I'm going to go ahead and I'm going to solve. This is one triangle. 1/2 times that 5.1 number and don't forget, if you're doing all this work, please make sure that all your parentheses are good, because otherwise the calculator is going to spit out something ugly and it won't be the right ugly. So we can go through and we have the area equals 12.38743,728. And again, make sure you use the entire number because we are doing math with this and we're gonna get an answer that's not exactly true if we round early. And in fact, if you typed in 5.10390485 into your calculator instead of this whole thing that I put in, you might find that your last couple digits are not exactly the same because you're already starting to see error. But that's okay. You should be fine being off by a little bit because we're just rounding to the nearest tenth. The error shouldn't creep that high anyway. And then all we have to do for the last thing is just multiply by how many triangles there are. 1, 2, 3, 4, 5. And then just times 5 into the calculator. You get 61.937 18642. And again, you're by this point your error should have creeped in like 3 or 4 digits probably. And that's okay. We're not worried about that so much. Our final answer here, 61.9 feet squared. Your turn. Give it a try. Alright, so first thing we have to do is we have to find the radius. So, let's find the radius. Remember, we want this guy up here. The radius. Right here. So let's figure out our let's get our triangle going. And we are looking for this. We've got this, right? When we cut this in half, we end up with this being, wow, that's bad, but that's okay. We end up with this being 2, right? And then all we need to do is figure out what this angle is. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of those. So the whole big angle, I think, is 40. Yeah. So this angle here, this whole angle is 40. So this angle better be 20, right? This angle is half of whatever we're trying to find up in here. And then it's the same thing as before. Sine of 20 equals 2 over x. So x equals 2 over sine 20. Once we're done with that, we're going to go through and we're going to actually solve our problem. So one triangle area equals 1/2 2 over sine 20 squared times sine of 4. Should close all your parentheses. So you go through, you get one triangle, 1/2 times 2 over sine 20 squared times sine of 40. We get roughly 10.9 something. And again, don't round yet because we need to find all of the slices of pizza. We need to multiply by 9 because there's 9 of them times 9, and you get 98.909187 yada yada yada. And then we round to the nearest tenth because that's what it tells us. This is too small, it goes away. 98.9 meters squared. Ta-da! Next one. Again, give it a try on your own, make sure you can do it, and then we'll go over it together. Okay, so same thing. Find our radius. So we're going to go through. This one's going to be slightly more ugly because 7 is just an ugly number all around. 360 divided by 7 is not a good number. It's like 51.42857,143. That's ugly. I'm going to use that ugly decimal number in my calculator every time. I'm going to write it out here for simplicity's sake as 51. It's not exactly 51. Please don't use the exact number 51. I won't. You shouldn't either. So divide that ugly number by 2. Get like 25.7 something. So sine of 25.7 something equals this is why it's important to write things out. See, I'm already trying to be fancy and not write it out, and I am making mistakes. So learn from my mistakes, write things out, draw them out, make a picture. It does help. I promise you, 25.7 something. This side is 3. This is what we're looking for. So sine of 25.7 something equals 3 over x. So x is going to be 3 over this sine of 25.7 something. It's an ugly number. I'm sorry, we have to use it. So there's our radius. And we're just going to do in the calculator 1/2 3 over this sine of 25.7 something squared times the sine of 51 gross something. And then that is going to be our answer. So 0.5 times parentheses 3 divided by that number in the sine Okay. You can't see this, but I'm making lots of mistakes, so I'm trying to go slowly so that I don't mess up. Times the sign of the 51 something number, and that goes in. Um, and we should get something on the order of 18. That seems about right. 18.68869258. That's one triangle, and then there's 7 of them, so times 7. You get area equals 130 times 820,848, and we round to the nearest tenth. This goes away because that 2 is too small, so we get a final answer of 130.8 kilometers squared. All right. So at this point, you are capable of doing everything. Hooray! If you have any questions, go ahead and send me an email. I'm always around. What else am I doing? I'm staying at home, quarantined, doing a lot of cooking, washing my hands all the time. So hopefully each and every one of you is not going crazy, and I will talk to you again. Have a wonderful day.